Welcome to Podcast Learn and Fun. Let's start today's journey of learning. Have you ever thought about all the crazy stuff flying around in space and how we're protected from it?
You're thinking about Earth's magnetic field.
Yeah, like Earth having this invisible shield.
It's more dynamic than a simple shield. This force is generated deep within our planet in the outer core, where molten iron is constantly churning and flowing. And this movement creates electric currents, which in turn generate the magnetic field that surrounds us. It's a bit like a naturally occurring dynamo, constantly in motion.
Okay, so it's always moving. Does that mean the field itself is unstable?
The field is constantly shifting, yes, but it's more about gradual change over long periods.
Okay.
Think of the magnetic poles. We all know about north and south. Well, those poles actually drift over time.
Really?
Yeah, and every so often they flip entirely.
What?
Yeah, this flipping process has happened many times throughout Earth's history and left a record for us to uncover.
Wow, a complete flip of the magnetic poles. That's kind of mind-blowing. So how does this magnetic field impact our everyday lives?
One of the most direct ways you might have experienced the magnetic field is through navigation.
Okay.
Think about a compass. It works because its needle aligns itself with the Earth's magnetic field lines, pointing you towards magnetic north.
I actually do use a compass when I go hiking, so I've been relying on the magnetic field without really knowing it. I've noticed on my compass, though, that there's a difference between true north and magnetic north. What's up with that?
That difference you've observed is called declination, the angle between true north and magnetic north.
Oh.
And it varies depending on where you are on the planet. There's also inclination, which is the angle between the magnetic field lines and the Earth's surface.
Huh.
Both declination and inclination are important for accurate navigation, especially for ships and airplanes that need precise directional information.
That's super interesting. So it's more than just a simple north-south pointer. It's all these angles and variations. It makes you realize how complex this invisible force really is.
Absolutely. And that complexity is key to its protective role. The magnetic field acts as a shield against the solar wind, which is a constant stream of charged particles from the sun that bombards the Earth.
So it's like a force field deflecting a constant stream of energy. What would happen if we didn't have this protection?
Think of a ship cutting through water and creating a bow shock. The Earth's magnetic field does something similar, pushing the solar wind around our planet, deflecting most of those harmful particles.
Okay.
Without it, our atmosphere would be constantly eroded, and life on Earth, as we know it, would be impossible.
Okay, so it's deflecting most of those particles. What happens to the ones that get through?
Some of those charged particles get trapped in regions called the Van Allen radiation belts. These belts are donut-shaped zones of intense radiation that surround Earth, kind of like a magnetic bottle holding these particles in place.
So even with the magnetic field acting as a shield, some of that solar energy still manages to get caught.
Exactly. And these trapped particles can actually have some beautiful side effects like the auroras.
Oh, yeah.
When these particles interact with the Earth's atmosphere near the poles, they create those stunning displays of light.
The northern lights, I've always wanted to see those. So it's this interplay between the solar wind and our magnetic field that creates those mesmerizing light shows.
Precisely, but it's not just pretty lights. These interactions highlight how dynamic the system is and raise questions about what might happen if the magnetic field were to significantly weaken or even flip.
You mentioned earlier that these flips have happened before in Earth's history. What kind of impact did those flips have?
The geological record shows us that these flips have happened many times over millions of years. The exact effects of these past flips are still being debated, but it's clear that life on Earth has persisted through them.
That's reassuring. But with all our technology today, wouldn't a flip be more disruptive than it was in the past?
That's a valid concern. We rely heavily on electronics and interconnected systems.
Right.
Imagine the impact on our communication networks, GPS systems, even power grids if the magnetic field were to significantly weaken during a flip. It's a challenge we need to be prepared for.
It makes you realize how vulnerable we are to these invisible forces. What are scientists doing to monitor the magnetic field and prepare for these potential changes?
There's a global network of observatories and satellites constantly monitoring the Earth's magnetic field. They track the movement of the magnetic poles, measure the field's strength, and look for any signs of weakening or unusual activity. Think of it as having our finger on the pulse of the planet's magnetic heartbeat.
So are there any early warning signs that a magnetic flip might be imminent?
It's not that straightforward. While we can track the movement and strength of the field, predicting a flip with any certainty is still beyond our current capabilities. There are some intriguing theories and models, but it's an active area of research.
I see. So it's a bit like earthquake prediction. We know they happen.
Ah,
But pinpointing the exact when and where is still a major challenge.
that's a good analogy. But even though we can't predict flips with certainty, we can learn a lot from studying the past behavior of the field.
And use that knowledge to develop ways to protect our technology and infrastructure.
Exactly. There's a lot of research focused on creating more resilient technology, things like designing satellites with better radiation shielding or creating backup systems for power grids.
It's all about adapting and innovating, just like life has done throughout Earth's history, to survive these magnetic shifts.
It's a reminder that we're part of a much larger system, interconnected in ways we're only beginning to understand. And the more we learn about the Earth's magnetic field, the better prepared we'll be for whatever the future may hold.
This has been a fascinating deep dive into something we usually take for granted. We've covered a lot of ground. Is there anything else you think our listeners should know about the Earth's magnetic field?
I think the key takeaway is that this seemingly invisible force plays a critical role in making Earth habitable.
Yeah, it's like we don't even think about it, but it's so important. It's a reminder that there's so much more to discover about our planet, and like that the pursuit of knowledge and understanding is crucial for our future.
I couldn't agree more. The Earth's magnetic field is a testament to the complexity and wonder of our planet. And it's a field of study that continues to yield fascinating discoveries.
Thank you for listening to Podcast Learn and Fun. If you like our videos, please subscribe, click the like button, comment, and share. See you next time.